I'm Ross, and today I'm going to show you how you can use async local storage to create a server-side store that stays coherent in an asynchronous context. So this is a little hard for me to wrap my head around, so I decided to write a blog post and make this video about it to make it a little easier to understand. There are a few framework implementations of async local storage. We're seeing it used more and more in different frameworks lately. It's actually been stable in NodeJS since 16.4, but recently we've seen Next.js implement async local storage in their after function, and SvelteKit recently added the getRequest event function that utilizes this API under the hood as well. So you can access the event object, which you would typically access in a load function, and then pass down to any functions that needed properties on the event object. Now you can just use this getRequest event helper, and you can obtain the event in any function that is used within the scope of your load function. Support is great in popular server-side JavaScript runtimes. It's obviously available in Node, and then Cloudflare, Dino, Bun, Vercel Edge Runtime, and I'm sure other ones as well have all added support for this. But at the current time, it's not supported in the browser or in web containers, so one caveat is it won't work on platforms like StackBlitz if you're running your server-side code in a web container. So this is mainly just a server-side API as of right now. So here's an example of how you can use async local storage on your web server to store the request object and access it in any functions that are within the scope of your handler. To get started, I'll show you without async local storage. If you wanted to pass the request around through different functions, what you would have to do and what it might look like. So here's a quick example. Our entry point is this fetch function within our default export, and we just log the current URL and then we pass the request into our handler. From there, our handler does some asynchronous work, so maybe you could think of this as updating a value in a database or getting a value from a database. And then all it does is get the path name, which it uses a little helper function to do. So we're again passing our requests into there. What getPathName does is it creates a new URL and it extracts the path name, logs it, returns it, and then that's passed back into our response in our handler, which is then returned in our fetch function. So you can see it's common in applications to create lots of different functions to handle different actions that you want to take, and this is kind of a 3-function example of a simple request handler and what it might look like. You can see the main thing here we're doing is we're passing around the request object. So that request that initially is obtained within fetch, we have to pass it to handler, and then we have to pass it to getPathName, and then it's used within getPathName and passed into new URL. What async local storage does is it allows us to not have to prop drill or pass this request through all of these functions. At first glance, you might think it's easier just to assign a global variable for the request. And then you could set it in the initial fetch function, and you could remove your request arguments and not have to pass it through. Then, to get our rec, we would say this equals the global request, and then we're able to just access our request here and set it, and then in getPathName we can access it when we need it, and we don't have to pass it through the handler. There is an issue with this though, which I'll demonstrate here. Because we have some asynchronous work, in our case we have this delay, if we make a request to 1, you can see we get a 3-second delay and then it returns the path name. So just to demonstrate the issue here, I'll make a request to run, and before it completes, I'll make another request to our second route 2. And you can see here we get the path name of 2 back twice. So our global request our first request comes in, it sets the global request, and then we're stuck waiting. Our second request comes in, it sets the global request, and now that same global request is used to get the path name for both of our routes. This is exactly the problem that AsyncLocalStorage allows us to solve. We can create a new AsyncLocalStorage instance, and as a generic, we can tell it we're going to store a request as the store. We can make our helper function similar to maybe how SvelteKit made theirs. We'll make a getRequest function, and what this will do is it will get the store out of our AsyncLocalStorage, and the type of the store is either going to be a request if it's there, or undefined if we're outside of the context. So if we're outside of the context, we shouldn't be using this method. So we're just going to throw a new reference there. And then we'll return the request if it's defined. So that'll give us a really nice helper method with a type that we don't have to check every time we use it. So it's always going to return the request, or it'll throw an error if it doesn't. Now, instead of setting our global request here, we'll use our AsyncLocalStorage, and we'll say storage.run, and this is a method on the storage class that allows us to run a function with a certain value in local storage, and it's only going to exist for that specific function. So in this case, we'll want to pass in the request, and then we can pass in our handler as the second option, and whatever's returned from handler is also going to be returned from this run function. Now we don't need to pass requests into the handler at all. This function will be completely skipped because of AsyncLocalStorage. And then instead of getting our global request object here, we're going to use our getRequest method. And now that getRequest method, since it's being accessed within the scope of this run method through handler and then through getPathName, will return the store in the context of the actual run. So let's try it out again. We'll make a request for the first path, and then quickly make a request for the second path. And you can see we get the correct path name back for both of those. We can see 1 and then 2 come back. So you can see how this might be useful. This is a pretty simple example, but say you had a lot of different functions between your fetch and your get path name. That would prevent you from having to pass the request as an argument all the way down to get path name. Also, now get path name is a little helper function. If we have a lot of different handlers or different components and we need to get the path name within any of those components, we can use get path name wherever we need it and not have to worry about passing down the request argument to it. It will always return the path name for the request that we're currently processing. I hope this makes AsyncLocalStorage a little easier to understand. Let me know what you think of this video. If you'd like to see more videos like this in the future, please click subscribe or like this video if you enjoyed this content. Thanks for watching. Have a great day.